We are recording. So at least it should pop up. There it is. We are rolling. So our topic of today, I will spend whatever time you want on what I'm going to have to do here. I'm not sure what my visibility is going to be. It's going to be awful. I do have previous semester discussion of this, so I will get a link to those as well in addition to this. So hopefully that would be the combination of this plus the discussion from the previous semester will take care of you. The one proof that we really want to try and deal with is using something called the pumping lemma. And that pumping lemma says that any regular language is going to have a certain property to it. I'm flipping over to page 78. And I know that people find this a difficult topic. I've seen a couple of different presentations. I've seen a few things actually on YouTube that are quite awful because they actually do it wrong. Yeah, I would have set up, if I'd known this was going to happen, I would have set up my let's see, I can share some stuff. We can work some stuff here. We'll make it work. I have a graphics pad that is not up and plugged in and everything. So let's try to cover what we can. And I'm going to refer to yeah, let me do some stuff with drawing with my mouse is truly awful. But let me let's see if we can put down some let's see, do I want Word? Yeah, I want to make a Word. Stand by, please. We're making it work. And I also have a file, another explanation of the pumping lemma that I will upload and put in the files, and I'll send an announcement showing that. But let's look at, let me share my screen here and see what we can do. Oops. I love that Teams changes its user interface randomly. All right, so you should see my Microsoft Word. And I am typing. Are we good? Are we on board? Are we getting the screen? Oops, let's see. I'm guessing not. How about now? Okay. Yes, like I said, Teams changes its user interface from week to week just to make sure that users don't get overly used to what they're doing, and be able to replicate it. So here's in simple words what the pumping lemma is expressing. Basically, here in short, I'm looking at page 78 in the book. I will post this document when we get done with it as well. So the pumping lemma says if A is a regular language, here's a key element, and it's infinite, meaning it has cycles in it that still lead you to an acceptable string. We've looked at a couple of finite languages where you have to specify each character of the string, of the strings that are in the language. Here, this is the short version of what the pumping lemma says. It's stated in more detail, in more formal detail on page 78 there. But so if RA is a regular language and it is infinite, it has the property that there is some there exists. There we go. Some string there we go. While typing. A long enough length P Okay, so let's think about this in the words first of all, and see if it sounds. What I would like to get first of all is that you can buy into the notion of this, right? A is a regular language, and it's infinite, so it takes care of the, there's not just 3 strings in it, which would prevent any cycles potentially from happening. But now if you put a long enough string into an infinite language, think about what that means in terms of a DFA, then there is some repeatable section in that string that you can pump in or repeat that substring as many times as you want. Okay, so I'm going to flip over to the chat. Respond to this in the chat, please, where I am just going to say, can you affirm this? I think the repeatable section idea sounds reasonable. Okay, so if you can just, thumbs up or thumbs down on that. If you're not seeing it yet, and we'll spend a little more time. But the idea, and I'll draw a draw a little picture to hopefully illustrate. Oh yeah, it looks like a lot of you are on board. Good. Yep, here comes an example. And someone borrowed my my nice little USB separate camera. So I'm stuck right now with the just my built-in, well, my nice actual video camera that is not interfacing at the moment, and my built-in integrated little on the laptop camera. So not non-optimal, right? So we'll look at an example here. This is just a, I'll stop sharing my screen for a moment and see if we've got camera back. Ta-da. So here's my little example. I know, I'll try to clean this up afterwards. There's a nice, I have a better real life video too that I'll send you a link to, but here's a nice little DFA, and you can see that it loops from Q0, loops on a 1, and it needs a 0, and basically, can you come up with some words? Anybody in the chat, come up with some words for what do you think the accepting language or accepted language is for this little DFA? Somebody got some words to describe and recognize this guy? Please, please. Yeah, so we might word it, you got it right, Nick. We might word it as accepts strings of zeros and one, strings over the alphabet, 0, 1, that end in 0. And that would be a sufficient description. Now, tell me this, can you come up with any repeatable part of this that, or let's say, what length string would guarantee that you had some repetition of states going on for an acceptable string? Now think about this a little bit. There's a minimum length. Oh, careful. This does not require even number of zeros. If you look at it, I can start in the start state there, Q0, and a single 0 will get me over to the finish state, the accept state. Yeah, so I can have 1, 0, any number of zeros, 1, 0, 1, any combination of zeros and ones, as long as I end up with a 0. A 1 takes me out. And basically, we could come up with the definition of those two states, the meaning being Q0 would say I've seen ones, and I'm ending in a 1, and Q1, the accept state, would say I saw at least a 0, and I'm staying here because I'm only seeing zeros, right? But now, if I put in, let's just try, if I put in a single 0, have I repeated any states in traveling through this this machine here? If I give it a single 0, did it repeat any states in getting to the except state? No. So that is a string. So the string, single string 0 is in my language. We agree on that. But with a string of length 1 that is in the language, did not repeat any states. How about if I give it a string of length 2? If I give it a string of length 2 that is in the language, did I have to repeat any states? If I give it a string that is 2 characters long, and it is in the language, did I repeat any states? Yes. Yes. So there are 2 different strings, right, of length 2. How many strings are there of length 2 that are in this language? Well, there are 2 of them. All right. And we can enumerate them. Yep, there you go. No, not quite. Armin, close. We can either do 0, 0 or 1, 0. And those are the only strings of length 2 that are in my language. No problem. Yeah. So if I do 1 repetition, could I do more? If I repeat any state in an NFA or a DFA, then I will necessarily be able to do that as many times as I want. And this is what's getting into the nature of what a regular language, what the characteristics are of the regular language. And this is what the pumping lemma is telling us, is that for any DFA that is for an infinite language, there will be some, if you give it a long enough string that is in the language, then you would have had to do a repetition. And if you can do 1 repetition, then you can do an infinite number of repetitions. Make sense? And what we're going to use this for, there's actually a purpose, really, for going into the pumping lemma, and that is to identify a language that might not be regular. Okay, so we'll, I'm going to go back to my little document here. But this is, here's the picture to hang on to as we're talking about this. So in any DFA that will accept an infinite language, okay, there will be a minimum length string, and we'll call that the pumping length. And if you feed that DFA a string of the pumping length or longer, then you're guaranteed to repeat you feed it a string, and here's a key element. You feed it a string that is in the language, and it will, if it's of length P or greater, then you're guaranteed that there was at least 1 repetition in the creation, or in the accepting of that string. And so as we look at this one, would a string of length 1 have any repetitions in it that is in the language? A string in the language of length 1 I'll tell you, it has no repetition of any state. However, a string of lengths that's in the language would have to have at least one repetition. You'd either have to loop to get the 0, 0, you would travel from Q0 on 0 to Q1, and then you'd have to loop back on Q1 again to get the second 0. If it's length 2, there's only 2 strings that are length 2, we note. So if it's another string of length 2, that the only one of those is 1, 0. To get there, you'd have to loop on Q0 with a 1, repeating state Q0, followed by the move to Q1. So the pumping length that we'll be referring to here in a minute for this DFA, the pumping length for this DFA is 2. Any string that is in the language that is length 2 or greater must have a repeating element in it. And if it repeats one thing, then I can make any number of repetitions of that same, whatever got repeated. I can do that as many times as I want, and I still get a string that's in the language. So if the string is odd, now think about it. I could do 1, 1, 0. And that would have a repetition on Q0. So simply length being odd does not eliminate repetition, right? 1 is the only length that does not repeat. Any string of length 2 or greater, because there's only 2 states, any string that's in the language of length 2 or greater had to repeat one of those states, right? So you get you have to use up a character, right? It takes 2 states to use up 1 character without repetition. Okay, so we'll press on here. I'll share my screen back to my little document again. And I would, you can look in on page 70, whatever I wrote there, 78. There we go. Hopefully you are, it says you are seeing this. But we'll first understand how this thing works for something that is a regular language. That is, remember, so the machines that we'll be thinking about are NFAs, or it's a little easier to see it with a DFA, I think. Remember, they are equivalent to each other in power. And so let's stick with thinking about it in terms of the DFA. And I think what we illustrated was if there are n states, the pumping length if there are 5 states, then a string of length 5 would have to travel. Now, we don't know that it would visit. Remember, we can have complicated DFAs. But as we showed on this little 2-state DFA, if there are n states, the pumping length, in other words, this is, remember, the pumping length is the number of characters that you can feed into it before you have before you must have a repetition. So pumping length can be less than the number of states. If I just had the two, if I made my Q0 and my Q1 on our current little DFA, if I made them both accepting states, what would the pumping length be? Requiring you to repeat a state to get an acceptable string. Okay, so if Q0 okay. If Q0 in that example, in our 2-state one, if Q0 is accepting, be careful, what's the minimum length string that would repeat a state string that could be entered, string could be entered, that would give an accepted string. Yeah, I saw Ron's 0. 0 is the minimum length string that would be accepted by this DFA. That is absolutely true. So because the start state is an accepting state, we would have the empty string being accepted as well. But if that does not repeat, right, we just start in Q0 and we have nothing in the input, we would just say accept. But we didn't actually leave state Q0 and return to it. So what I'm illustrating here is the pumping length is shorter in this case shorter than the number of states. But you can't have, imagine, again, what is the nature of an infinite language? Must have looping in the DFA. By definition, the DFA is what? A finite automaton, right? So if the language is infinite, the only way you can get an infinite language is you have to go through some, we don't know which, it doesn't matter, some sequence of states, and somewhere in there you're going to go back and repeat one of the states that you've already been in. And then you can actually have any length, not necessarily any length, but you can have an indeterminate number of strings, right? It may require them to all be odd, it may require them to be even length. Yes, it would have. When we think of the definition of what we mean by repeat, when a character is used up in the character, we say the current state is left. So if you consume an input right on Q0, yeah. So if you start it at Q0 and you see a 1, the 1 is a transition which would say I left Q0 and then returned to Q0. So the nature of the DFA is that we always, on every input character, we leave a state that we're currently in and we go to a state. It may be the same state. That counts as a repeat. That counts as returning to it. So that's it's subtle, but it is even looping on itself is considered a repetition, a cycle in the DFA. Yeah, and Nick says we can repeat from there once. We can actually repeat from there, right? At least once. Good, perfect. Yep, you can keep going there if you want to. And so I will. I've been on the chat there. Hopefully, I've been typing some stuff in the chat, and if you have that turned on, you'll be able to watch what's going on there as well. Back to my screen. So just to, I want to. This is kind of self-evident if you think about it. So the nature of DFAs in regular languages, oops. They have repeatable sections, one or maybe lots of characters per repetition. If the language is infinite. So that means regular languages, you could require repetition of certain strings in order to, or certain substrings, I should say. So here's a another little example. Let's see here. Stand by. And here we go. There we go. And we'll accept. Here's a more complicated little language. All right. Here's a happy little, any Bob Ross fans out there? Here's a happy little DFA. Bob Ross, the artist, used to have happy little trees in his drawings. So I have happy little DFAs. That is a, it's not fitting real well. Yeah, there we go. We can adjust, right? Auto zoom. So here's a 4-state DFA. You'll notice that we can look at this a little bit. We can start with ones, and then end with a 0. But now, if I want to have a second, if I follow that 0 with a 1, it takes me to the dead state there, right? There's my null state, dead state. What I need to do, if I have 1, 0, this is requiring me to what? To get back to my Q1 as my only accept state. So if I start in Q0, do some ones, if I put in 1, 0, I'm good. But if I want another 0 next to that one, I have to jump over to, that's a, this is a smudge. That's a whoops there. So that's nothing. If I have a single 0 to get me to Q1, then I have to follow that with a 0 and either a 0 or a 1 to get back to Q0. So the repeated part inside here is that I could have, in order to get back to Q1 again, if I took the trip around the loop, the repeatable string would be a 0 followed by 1 or 0, followed by any number of 1s, followed by a 0 to get me back to Q1. And so the whole repeatable part, we'll see if we can, hopefully you can grab that image there. Again, seeing that it's a null state at the bottom. And I want to write the regular expression for this on in my document. But hopefully you've got that jotted down and you can compare it to what we're going to do next here with the regular expression. Okay. And that is going to be all right. So for the 4-state DFA shown, I'll add an image for that to this too. The regular expression for this guy would be something like 1 star That means any number of stars off of Q of ones off of Q0, followed by a 0. And then we're going to put braces around this repeatable part that you can have any number of. See, make sure you can follow where we're going here. So I can let's see here. Let's space it out. I'm going to try to oops. The 1 star comes from come on, don't mess with me. Q0, and thanks for capitalizing that when I don't want it. Okay, and then the 0 is excuse me, getting to Q1. And so what's the repeatable thing inside here? I check over on the chat. Can you fill in the goes inside that? It's supposed to be a open close star. See where we're going here? What should we put into those brackets? This is a repeatable section, right? We can put in, well, it has to be a 0 to get the only way out of Q1 that will be successful and not be in the dead state is going to be a 0. Yeah, Jordan's on the track of it here. Nick, good. So we can get let's look at it here. Where's my trying to get it to where I can see my document. There we go. Okay, so we actually I messed with you a little bit because we actually have a bracket that's going to allow either a 0 or we have to have a 0 followed by a 0 or 1. This is you did it as well with the you had the alternating bar as well. So we could write this with the vertical bar. Either one is, you know, this one's a little bit the 0 followed by a 0 or 1, and then we're not quite done. We could have another. So this gets us back to where? This gets us back to Q0. We can have a 1 star, and there might be a shorter way to this, but to capture the whole thing, we have this. I don't think this one will lend itself to shortening, but this, if I can, we have a trip on the 0, we get to Q2. Then we have a 0 or 1 to get us back to Q0. and one star is also on Q0. Maybe I'll do it this way. And then that 0 takes me back to Q1. And I can do, you see, so here's the whole regular expression. There wouldn't be any spaces. I put the spaces in to show the states. Maybe I'll put out here that and so I've just put some spaces in between those. You would normally write them next to each other. And this is the trying to map the corresponding state that you're dealing with to the character that got you there. Okay, and clearly I can point out some repeatable sections here that I could select. In this case, you can do 1 star 0, and that gets you to Q1. But then you have to do an entire trip with all of this stuff. The 1 star is optional, but you need another 0 to get back to Q1. And then this whole string, do you see this is the repeatable part? Just trying to show. To get a string in the language, okay, do you see the justification, the understanding of why this statement is true? Oops, I lost my, there's my mouse. Okay, so once I should maybe say but once you get past the, you had a single 0 to end the thing, then to make longer strings, there's a couple of ways you can do that. There's a 1 star that you could repeat. I should say one of the repeatable parts is 3 characters. You have to have at least a 0 followed by a 0, or a 0 followed by a 1, and then another 0 if you're going down the path to get the a 0 followed by a 0. Okay, so of importance, the pumping lemma cannot prove the language is regular. Why? Well, not seeing the, notice that the pumping lemma says, you give me, it's pumping lemma avoids machine specifics beyond establishing oops. All right. If you oops, I laid my book down. If you look at now, let's look deeper into the definition here. We're saying in a different way, any string longer than p characters be broken into three substrings. Call them X, Y, Z. Oops. Can I superscript it? Boom. That's tricky, right? It's always fun to watch somebody edit. Oops, in the wrong place. There we go. We'll get it. Okay, just repeating what you're saying. The length of Y and so it can't have a zero length repeatable part. And here's the vertical bars mean length. Okay, so what I've just spent some time on purpose, this is where the book starts, is with this statement. And hopefully what we've done is talk through in a little more detail what we're talking about here, that there's a repeatable part. So now that we've seen an example with a little bit more than just a simple case, or a simple one character repeating or something like that, hopefully this gives you the gist of what this little guy is trying to say here. Fix up my italics, and we can't prove that a language is regular in this case, because we'd have to show that all the strings are, we'd have to do every combination of strings to show the positive case. And so what we're going to use is we're going to use the pumping lemma to show if language is not regular. So I am getting ready to finish this up here. I will send you an announcement with the another little write-up, and I urge you to read page 78, 79, and then the examples 1.73, 4, 5. I'll put that in an announcement. So a non-regular language cannot be accepted by a DFA. Here's an example, something like 0 to the n, 1 to the n. I'll make these guys, which one? Superscript. Always fun to do superscripts. Oops. Unsuperscript, please. How can we tell this isn't regular? What are some, let's see, we're just about at our time limit here. Think about how you would write a DFA that would accept this language. You see the problem? We know that a DFA cannot count. Right, it could count, you could set it up to accept strings that contain 3 1s or 3 Bs or something, or 2 As followed by 3 Bs. You can do those kinds of individual things, but it cannot count in the abstract sense of how many things are there here and then use that value. So but cannot tell that, say, 5 zeros appeared before 5 ones. Right? If we just had like any of our sample DFAs here, we would, you can loop as many times as you want. And what we're going to show next time is that for something like 0 to the n, 1 to the n, there's no repeatable part that you can pump into this that you could repeat that would give you a language, a string that's still in my language, right? Because you can either, if you repeat zeros, then you have too many zeros and not enough ones. If you repeat ones, then you have too many ones, and the ends won't match. Here, you can't arbitrarily add ones and still get a string that is exactly n zeros followed by n ones. And you can't add 0 ones in the center because you'd have 0, 0, 0, 1, 0, 1, 0, 1 followed by ones. That's not in the language either. So that's where the argument is going to go. We'll call it a night here. I will post this document. I'll stop sharing, stop recording. And you should have access. Now that we have a team set up for this class, you should be able to just go to the team and find the videos. I will also, for the previous videos, I'll get a link set for you. But for now, I think we are done for the evening. We'll continue. The exam is scheduled for a week from today. So we'll do review next time. I will put some exam details. One of those is I will allow you to have one sheet of notes, one-sided 8.5 by 11 sheet with notes on it that you can bring with you to the exam. The exam otherwise will be closed book, closed notes other than 1 page. And that will be planned as an in-class exam on 1 week from today. So I'll post that in an announcement and everything, but that should do it. I'll stop the recording and we'll see you next time.
Can I